Hey, this is OXDF. Today we're doing Advent of Code 2023, Day 10, Pipe Maze. Um, Basically, we're going to get a grid like this, and the grid's going to have these different characters on it. The most important things to note is we have these pipe values, and then like F7, L, and J represent different 90-degree turns. And then there's going to be one that's labeled S, that'll be a starting point. So presumably there's a pipe there, we just don't know exactly what it looks like. So in this case, you can tell the pipe has to be an F. Um, but then also they throw pipes all over the place that are not touching. So like this S still is an F. It has to, it has to do this bend, but these other pipes are just laying around. So you have to deal with clutter. Here's a more complex loop. It is important to note that there will be a loop in the pipe, and that's what we're trying to find. We're working off this loop that the start is on the loop. So here's an example of a start on the loop that kind of goes up through here somehow, like this. But then again, you clutter it up and you can't really see it with your eye. So the goal is to find how many steps along the loop, how many steps along the loop to reach the farthest point in the loop. So basically find the number of things in the loop, number of steps in the loop, and then divide by 2. Yeah, let's go ahead and take a look. Let's see, so if I do my Genday script here for 10, open this up. Let's take a look at the input. It's large, and it's a mess in here. Okay. Let's see if we can find start. So here's the start. We can see right away that this must be a J pipe because it goes up and it goes left. It can't go right and it can't go down because those pipes don't make any sense. So we know it's gonna be a J. We could just cheat and say, we know this is a J, but we're gonna make a generic solution for that. I guess there's not much else to figure out here. Let's open up the Python script. Let's see, I'm going to call this grid, and I think we can leave it just as a series of lines, at least for now. So what do we need to do? First thing we need to do is, we need to figure out where the start is. So we'll do that. We'll say for start art row line in enumerate grid. And then we can just say, I think we can just do try start C equals line.index of S. And if the index of S doesn't exist, it's going to throw a valuator, so a value error. We can do except value error. I think it's a value error. We could just be sloppy about it and just say except. And so we will just pass. Basically what it's going to do is we're going to loop over the lines. We're going to try to find S in the line. If S is in the line, we're going to set this. And I guess then we can also break because we found it. If S is not, if this S is not in the line, it's going to throw an error here. It's going to pass and loop around and do the next loop. And so we can check this. We can actually just say start row, start column. And now if we run this, Python day 10, we'll just go straight for the input and check it out. 5415. So row 54. I think we're actually going to be 55 on here because we're off by 1. And there it is right there. That's about 15 in. So I think we did good there. Awesome. Okay. So now that we found that, next thing we need to do is figure out the type. I'm gonna make a function for this because it seems worth. I don't know why. Probably kind of arbitrary. Def get start type r c, and what are we gonna do? So we're gonna say result equals this, and what we're gonna do is we're gonna loop over. We're gonna check the 4 directions around it. And then we're going to go to those pipes and see if the pipes connect back to start. And so what that's going to look like is we'll say for dr dc in, we can do 0, 1, 0, -1, 1, 0, and -1, 0. So for each of those, we're then going to say we need some way. So we need to go figure out. Take that value at that thing. So we're going to say grid of r plus dr, c plus dc. That'll give us the pipe. Now we're going to need a thing I'm going to call pipe map. And for now, we're just going to do this because we'll come back and fix it in. So now that we get the character, we'll say pipe map of this character, and that'll give us the 2 positions the 2 ends of the pipe. And so we're going to say for DRR DCC, I guess we'll do in pipe map like that. That looks fine. So now, what means success? Well, success is actually if dr and drr, like we moved off of it in one direction and we moved back in the other. That's going to tell us that we found success. So we can say if dr plus drr equals 0 and dc plus dcc equals 0, then we know we found a start. So we'll say res.append. And what are we going to do? We're just going to say dr dc because that's going to tell us the direction. Cool. And so at the end of this, I'm going to put an assert here, and this is always useful just for like checking your assumptions. I'm going to assume I'm going to find two outputs here. So I'm going to say the length of res is equal to 2. And so now we can say for, what are we going to do? We're going to loop over all of the pipe maps and figure out which ones line up nicely with this. So let's actually make a pipe map. Maybe that'll be clearer. So if we have a pipe, then we were going to go 1, 0, the row is going to change, or -1, 0, like that. If we have a dash, that means we're going to go 0, 1. We need a open thing there. Or we're going to go 0, -1. And we're going to need commas here. Okay. If we have an L, then we can go up 1, which in my, I generally when I do these grids, we're going to start numbering at the top left and count down. So if we go up 1, that's going to be -1 on the column, or on the row, 0 on the column. Or we're going to go right 1, which is going to be 0, 1. Okay. J is going to be the opposite, basically the same thing. We're still going to have -1, 0. But now we're going to have 0, -1 as well. Okay. We have F. See, so F is going to go to the right, and it's going to go down. So we're going to say 1, 0. And we're going to say to the right, it's going to be 0, 1, like that. And let's see, the last thing we have is 7, like that. 7 is going to be left and down, so it's going to be 1, 0, comma, and 0, -1. That we're also going to have dots. We need to take care of dots, and dots are just going to be empty because there's no moving on dots. I think that's all we need. Now we have that pipe map. We can say, okay, now we'll say for ch, moves in pipe map.items. We're gonna loop over the pipe map items, and we say if all moves in moves for move in res. Okay, so for each move in res, if it's in the moves for this direction, and all of those things are true, then we're going to return ch. So as soon as we find the one where both the two things there match up with the two things there, we return it and we've got the character. So let's see. What if we try get start type of start r, start. See, I've already forgot what we said that was supposed to be, but we thought it was going to be a j. Check that. It's going to go up and it's going to go left in this L. So that looks good. We're happy there. Okay. Now, what's next? So we need to, I guess we'll go ahead and, do we replace that? Let's replace that. So we're going to say grid equals, grid start row equals grid start row dot replace s with this. Grab that and put it there. So now we have updated our grid to have the correct thing in the starting spot, and we've got the coordinates start S and start C, so start R and start C, so we know the rows and columns there. Okay. Now, when I first read this, and I actually read this morning, and I've been out all day, so I've been thinking about this a little bit in my head. My first thought was like, oh, you just pick a direction in the loop and go. And then you can do that, but I think it's actually gonna be easier if we just literally do a breadth first search. That's like a pattern I do all the time in these program codes, or in these coding competitions, and it's just like worth doing. So we're just gonna say scene equals set. We'll say q equals deck, and we'll give it r comma c. I need to import that from collections import deck. Oh, not default deck. Deck. And deck is just a very hyper efficient queue for us to use. So let's see. So now I'm going to say while q, And so the first thing we're going to do is say r comma c equals q dot pop left. We're going to pull things from the left. It means we're just going to append on the right. If r comma c in scene, then we just continue. Go get the next thing. Otherwise, we're going to scene dot add r comma c that. And then we're going to say for rrcc in, and we're going to make a get valid moves r comma c q dot append r comma cc. So we're going to append all the next moves, and when we're out of moves, we've done a full loop. We're done. We'll have the result. We can even come up here and say len scene divided by 2, and that should give us our result. I'm going to pull the sample input here. Let's see, what was the first? Where's the one here? This is the one right here. We'll grab that, and we know that the results should be 8. Okay, let's see. ex.txt. Paste that in. All right, but we know it's not going to work yet because we have to do this get valid moves. Unless I'm just going to make a function for that because it just seems cleaner. Def get valid moves r comma c. And so what are we going to do? We'll say like pipe type is equal to get. No, it's equal to pipe map of grid sub r sub c. We'll get the pipe type there. Now we can skip over. We know that we're not going to run into anything with an s, which is nice. So we can just we just say return. Let's see. We're going to go for. I always have a hard time. Let's see. We'll do drdc in drdc for for drdc in, and this will be pipe map pipe type. So what we're really going to do is we're going to say r plus dr c plus dc. That'll be the next move, and we're going to do that. This right here is we're going to make a list out of that, give us all the valid moves like that. So we're going to loop over. We're going to put the pipe type into the pipe map, get out the possible differentials we're going to take, and we're going to return all of those. So we just need to return that. I think that's good. I probably didn't need to make a function out of that in hindsight, but oh well. I don't know, let's run this and see if we're anywhere close. Key error. All right. Oh, new line. We gotta get rid of new lines because we definitely don't want new lines. Let's see. So we're gonna come up here and grid equals read lines. Maybe we'll do l dot strip for l in read lines. That unhashable type list. Pipe type. Where are we here? This giant font makes it hard to get screen real estate here. We're at 30. So we're here. Let's put a breakpoint here, and we will F5 to run this. I believe it's going to run my example stuff. Yep, okay. So what do we have here? R, C, DR. DR is not defined. Okay. Pipe type is, oh, what? That's not what I wanted. Pipe map. I think I've pipe mapped twice here. Okay, so that should be fine. Let's try that. There we go, it's looking better. I guess we can let's run out through the debugger. 8. Oh, that's what we wanted, wasn't it? I already forgot. 8. Sweet. All right, let's go check it out and see if we can get ourselves a. So example gives me 8. Input gives me 6806. Let's grab that and try. Awesome. All right, I'm going to pause this and read part 2. Okay, so let me go back. In part 2 here, we are asked to find the area enclosed by the loop. And there's a couple tricks here that are worth noting right away. For one, you can see in this example, the answer is 4, and it's 1, 2, 3, 4. So this part's not enclosed, right? What's interesting is all of this stuff, there's no space in here, but if there was, it's enclosed as well. I think there's a better example to see. Let's see if there's one here. So the one that jumps out right immediately to me is like this LJ, right? This is not enclosed. Like this one's not enclosed because you can still go along this pipe and in. See if there's another example. I don't see anything obvious, but like if we are going, we can go along. There could be two parallel pipes, and if maybe I should draw. Maybe we'll do it this way. If you had something like this and this, and at the end here we had a 7, and here we had an L, oops, not an L, a J, and here we had an L, and here we had an F. The fox would be able to pass through. So like, let's say this stuff was all potentially enclosed. This is not, this stuff over here and this stuff over here would be both in the same spot, either both in or both out, because you're allowed to pass through here, even though there's no actual space between them. So that's a tricky thing we have to take care of when we do this. What we're gonna do, and I was just looking this up, is I think this thing's called like ray casting. And basically, the idea is if we pick a point, any point inside of the polygon, and we want to figure out if it's inside or outside. If we draw a point out, infinitely out, and we count the number of number of edges we cross. If it's odd, we're in, and if it's even, we're out. So you can see here, this is all out until we cross. Now we're in. Now we cross. Now we're out. Now we cross. Now we're in. Now we cross. Now, and etc. So we can actually just start on one edge of our map and work our way to the right, counting whether we're in or out, and then we just flip those back and forth, and we'll be good. So let's go give it a try. Break this down. We will go for part 2 here. So let's see. Just start new space in here. So the first thing I want to do, I want to get rid of all the the stuff that's not a part of my circle, right? So I'm going to say grid 2 is equal, and just make ourselves a new thing. We can do for r, comma, line in enumerate line grid. For c, comma, char in enumerate line. If r, comma, c, and now what are we going to do? So we're going to say if it's in scene, or I guess we'll say if it's not in scene, grid plus equals, and we'll add a dot. Else, I guess we can do this on one line. We'll do grid 2 plus equals dot if RC not in scene, else char. And now with that, we should build ourselves an entirely new grid. And at the end of each row, we want to do grid 2 dot append. So grid 2 plus equals that. And that'll put us a new line on there. And at the end, we want to do grid 2 equals grid 2 dot split on that. So basically, after we get through this whole thing, we'll split it and make it so it's just like our previous grid. All right, now that we have our grid, we're just going to walk. We're going to walk each line. So we'll say part 2 equals 0, and then we can say for line in grid 2. And so for each line, we're going to start on the outside. We'll say outside equals true. Then we'll say for ch in line, and we can do a match on ch based on what we got. So if if we're on a dot, if not outside, part 2 plus equals 1. So we've hit a dot and we're on the inside. If case is that, so we hit a wall. We definitely hit a wall. What we're going to do is we're going to say outside is equal to not outside. So we're just going to invert outside. What else could we hit? Well, we could hit an F or an L or those things, right? So we'll do case. Now it's interesting. We cannot hit a 7 or a J first because those we know we're on our loop and we're coming to the side. So we're going to have to hit an F or an L before we hit a 7 or a J. Hopefully that makes sense. So we'll start with the F. If we hit the F, what are we going to do? Well, we want to start tracking that we're along a pipe now, because there's a big difference between when we go in here and we come across F like this, and then 7, that actually is not crossing a boundary because we've gone, this thing goes up, over, and then down, and so we can run right along it. But if we have F7 and then J, that is a boundary because it's up, over, up. And so we need to track whether we're going up or whether our pipe is kind of currently going up or down. And it doesn't really matter as long as we're consistent. So we're going to say whether the pipe is kind of, whether we're start F, I guess we can say start F equals true. Up here, we're going to say start F equals none. Let's see what else we can do. So then we'll say case of L. We'll say start F equals false. Then we have a case of we hit the line, and we're just going to do nothing. We should definitely assert that start F is not none. I think that's the way assert. So we want to make sure that that's actually not none. Now, if we get to the 7, we should assert, we want to make that same assert, not start F is none. And then if, so 7 is going to be a boundary if we started with an L. So if not start F outside equals not outside, we've crossed a boundary. And then we'll say up equal, oh, not up, start F equals none. Well, we clear our thing. Case of what's our last one? J. We're going to do our assert not start F is none. We're going to say if start F, so if we started with an F, then outside equals not outside. And start F equals none. We could probably do some asserts up here to make sure start F is none in those cases, but I think we'll be okay for it. We'll see if we can make it without these asserts for now. And then we're basically done. Yeah, because we'll just, every time we hit a dot, we're checking whether it's in. Otherwise, we're updating our current state to see whether we check it. And let's give it a try and see what we get. 1 does not feel good. Let's see. What's my example here? Oh, I have no idea what's on the inside of this one. Let's go check. Did they even give us the example of that one? Or should we just, let's grab a different example here. Let's grab this example. We know the answer to that one is 4. There's 4 inside. Ooh, nice, we got it right. Let's see, let's try this other example just to be sure. This one, they tell us 8 tiles are enclosed. All right, this is feeling complicated, but good. 449. Awesome. All right, this was tricky for sure. But the raycasting thing is really useful. Again, all we're going to do is we're just going to go across down each line and count whether we're in or out based on how many borders we crossed. And the tricky part is this, tracking F and L. I think there's probably an alternative way. I've been thinking about this. We could do this by, instead of we could just remove all these from the line. We don't need them. They're not useful. They're not part of the line. We could then look for F7 combinations and replace them with a pipe. We could look for LJ combinations and replace them with a pipe. Then we could just get rid of all the F and J's. Like we could shrink the line down so that we just have dots and pipes and then do the same thing, and that would probably work too. But this, this ran at instant speed. I'm gonna call this good enough. So, tricky, definitely trickier than yesterday. One of the trickier ones we had so far, but honestly not too bad once we broke it down. So, thanks for hanging out with me today. I will talk to you tomorrow.